Here's finally where you can use your actual calculator. Oh my goodness, I've done all of this stuff without a calculator, which is so cool. Now I'm going to give you a question where I give you a cosine, which looks really, really bizarre. It looks terrible, 0.6238, and it's negative. Okay, so here we go. Look at the question. It says, give me the measure of theta, probably the standard angle, the angle in standard position, to the nearest tenth of a degree. So, yep, guess what? We're back to rounding. Ah, rats. Oh, well. Remember your cast rule. Add sugar to coffee. Where was cosine? Because remember, it is negative. Where is cosine negative? Well, cosine is positive because everything's positive here. Cosine is positive here, meaning you got an angle out here and you have an angle out here. Okay, so let's do the first one. There's the angle out here. We're going to find the reference angle, of course, to the x-axis. So we're going to draw a triangle out here. We're going to note that the cosine of this angle is, well, let's clean it up because I can't even read that anymore, is negative 0.6238. We also know that it's going to be down in this direction. So I'm going to put it down to here. And again, there's my reference angle. Okay, there's my nice 90-degree triangle because, again, reference angle is to the x-axis. So how do we do this? Well, real simple. Don't include the negative. Why? Because the negative tells me it's here and it's here. Once you're dealt with that, you don't need that negative anymore. It's done. It's history. You know the angles are going to be here and here because of the cast rule. You're done. Just use the 0.6238. Well, let's find out what theta then is. How do we do that? Well, remember from Math 10C, you take the inverse of both sides. So the inverse of cos of both sides cancels this out, leaving us with a theta equals 2. So the inverse cos of 0.6238. Put up our calculator. Inverse cos of 0.6238. Boom. Enters. That works out to be 51.4 degrees. Okay, that means my reference angle is 51.4. That one and that one. Okay, and it's important. Remember, don't use the negative because the negative might just throw those numbers off for you. Now, how do we solve this now? What is our angle in standard position? Remember, standard position starts here, goes all the way over to here. All right, so doesn't that look like it's not quite 180? As a matter of fact, it's 180 subtract 51.4. And you're told to go to the nearest tenth, so let's do it. Let's go into our calculator, go 180 minus 51.4. Well, I just happen to have it there. Look, 180 minus second answer. Boom. 51.4. I'll even throw all the decimals in there to give me an answer of 128.6. So there's your answer. So this in standard position is 128.6 degrees from here to here. Well, how about our last one? From here all the way around to here. Well, there's 180 degrees again, but now you've gone past it. How far past? 51.4 past. Okay. So I know to add 180 added to 51.4. And with your calculator, all you have to do is mouse up here like this and pick that number and hit enter. And it'll take that exact number with all its ugly decimal places and crank it in there right there. And you've got 231.4 degrees. 231.4 degrees it is, and that's the angle in standard position. So do you see why it's really, really important to know what is a reference angle, what is an angle in standard position? And a lot of the calculations are built on this reference angle, and that's why those guys are so important.